Hello everyone. Today we are going to learn about quadratic equations. This is going to be a one shot video for your boards, for your JE, for your ISI-CMI, for everything. After watching this video completely, you will be able to solve almost every problem in quadratic equations. And mind you that quadratic equations is not only about solving a quadratic equation, it's much more than just finding out the values. There are many different kinds of problems that can arise. We're going to learn about all of them, and we're going to learn about them very quickly as well so that the concepts are clear to us. That's going to be our priority. So first of all, what is a quadratic equation? It looks something like this: ax square plus bx plus c equals to 0. I'm sure most of you have obviously seen, and maybe you have also done this kind of sums. But what is the condition for this to be a quadratic equation? Of course, a not equals to 0 is the utmost condition. Otherwise, there is no meaning, right? Because the leading coefficient term, which is a, and the coefficient of x square, which makes it a quadratic. The term quadratic implies that we have a x squared term with the non-zero coefficient. Yeah, otherwise, it's just a linear equation, right? Now, firstly, we have a formula called Sridhar-Acharya formula, which directly gives you two different values. The first value is given like this: minus b plus root over of b square minus 4ac by 2a, giving you one of the solutions. And the another solution is x2 equals to minus b minus root over of b square minus 4ac whole divided by 2a. Now we are going to talk about how we got these solutions and what are the benefits of using this directly in solving quadratic equations. First of all, this is called the Sridhar-Acharya formula. This is called the Sridhar-Acharya formula, also known as the quadratic formula, but it was Sridhar-Acharya who basically found this or maybe popularized this. I'm not really aware of the concrete history behind this, but this is what it's called. Now, you take the equation ax square plus bx plus c equals to 0. And how do you solve it? How do you actually get these two values? So a quadratic equation will always have two values, and they may be repeated values, they may be distinct values, or there might be no values at all if you're talking about real numbers. But otherwise, they will always have two values because it might be complex as well, right? So how do you solve it? You simply multiply 4a to both sides, and this makes 4a square x square plus 4abx plus 4ac equals 0, correct? Now, this is a very typical technique of completing the square. Therefore, the first term you can see is 2ax whole squared. You can write the second term as 2 times 2ax. What's left? There is a b left. So you write into b, and this is a 2ab form. You can see this is a square form, and what we need is an extra b square on both sides. So we simply add a extra b square, and therefore this becomes the first three terms. This, and this become 2ax plus b whole squared, and this becomes b squared equals minus 4ac, right? We just take 4ac to the other side. And with this, we will take the square root on both sides. But as we know that when we do that, we get two different values because we get a plus minus root over of b square minus 4ac like this. And now if you simply solve this linear equation, you will get x is equal to minus b plus minus root over of b square minus 4ac whole divided by 2a. Okay. Now, if you take the positive value, you get a root. If you get a negative value, you get another root. These roots are the values of x which solve the equation. So what are roots? So roots or zeros are basically the values. Okay, zeros. These are the same things. These are the values of x. Values of x that satisfy. So, for example, if you had an equation and you found out the answers x equals to 1 and x equals to minus 3, then 1 and 3 are going to be the roots or zeros of that particular equation you just solved. Okay? Now, we need to dive in more in this concept of roots. So, first of all, fundamental theorem of algebra states that an equation of, let's say, nth degree will exactly have n different roots, and that can be factorized. So in our case, what we have is a quadratic equation, right? With a leading coefficient a. Fundamental theorem of algebra states that this can always be written as a times x minus alpha into x minus beta, because it's a quadratic equation of degree, obviously the degree is 2. So there are exactly two roots, and the roots are alpha and beta. So you can always factorize a quadratic equation, a quadratic expression like this in terms of its roots. And this helps us find relationship between the roots and the coefficients ABC. So how do you do that? You simply expand this on both sides, since this is where identity. What is an identity? It is true for all values of x, right? Therefore, if you do that, you simply get ax square minus of alpha plus beta x plus alpha beta. And since this is always true, an equality of polynomials implies that when two polynomials are equal, their corresponding coefficients must also be equal. Okay. Now, you do see that, okay, there should be an A here, there should be an A here as well, because the A is multiplied. Now, since they are equal, we see ax square and ax square are identical, obviously. But then the coefficient of x must be equal, which means we must have b is equals to minus of a whole into alpha plus beta. And we must also have c is equals to alpha beta into a. And these lead us to the Vieta's relations, which is the sum of the roots of a quadratic equation is nothing but minus b by a, and the product of the roots of a quadratic equation is nothing but c by a. These are also called what? Vieta's relations. Vieta's relations. Now, example. So, how do you actually solve this kind of questions? Why are these useful? So, let's take an example: x square minus 7x plus 12 equals to 0. Let's say we were going to solve this equation. Obviously, you can solve it using Sridhar-Acharya. You can solve it using middle term factorization. But what else can you think of? What are the roots here? So, as I told you, if this equation has roots alpha and beta, then first of all, the sum of the roots will always satisfy what? Minus b by a. Now, in any quadratic equation, you first need to find out what are the coefficients. So, what is a here? A is 1 because 1 into x square. B is minus 7 because plus bx. If you remember the general form, you have to compare it with the general form, right? Like this: ax square plus bx plus c. This is what you need to compare with. Now, what is C? C is going to be 12. So alpha plus beta is nothing but minus of B. So minus of minus 7 by A. A is 1. And this gives you plus 7, right? Similarly, the product of the roots is going to be C, which is 12, divided by A, which is 1, and you get the value plus 12. And therefore, you get alpha plus beta is 7 and alpha into beta is 12. And it's very easy to see that alpha is 3 and beta is 4, or alpha is 4 and beta is 3, but it doesn't matter because 3 and 4 are the roots. It doesn't matter what alpha or beta is, right? So 3 and 4 are the roots of this equation, which would also mean since the leading coefficient is 1, you can also factorize this equation like this: x square minus 7x plus 12 would be equals to x minus 3 into x minus 4, right? Now, many different questions, the most of the questions revolve around the fact of where they involve roots here. So, what you can do is this. So, suppose you're given something like this, that you have a equation, let's say x square minus 5x, and then you have something like 1 equals to 0. And this equation has the roots alpha and beta. Okay, let's say you have these. So if this equation has the roots alpha and beta, and they're asking you, can you tell me what is the value of 1 by alpha square plus 1 by beta square? Now, these are the questions that you have to expect, that they are going to ask you value of some expression in terms of alpha and beta. Now, once this happens, what you are going to do is this. You're first going to write down the Vieta's relations, which is alpha plus beta here would be 5, right? And alpha into beta is going to be 1. Now, once you have that in hand, you start with the expression 1 by alpha square plus 1 by beta square. It's just like algebraic solving. So that is something you need to master, how to manage and manipulate expressions. This is something you learn from class 7 to class 12 continuously when you start learning algebra. And these basic techniques come in very handy. Therefore, we get alpha square plus beta square in the numerator. What are the values that we have? Alpha plus beta and alpha beta. Well, if alpha beta is 1, then alpha square beta square is nothing but alpha beta whole square. We shall write that this is nothing but alpha beta whole square. And what is alpha square plus beta square? Can we write this in terms of the known quantities? Yes, of course we can. We can write this as alpha plus beta whole square minus 2 alpha beta, right? Now everything is in order. So 5 square minus 2 into 1 by 1 square. And if you were to evaluate that, that is 25 minus 2, 23 by 1, 23. So 23 is going to be your answer. I think that should be clear. Okay. Another type of questions that you may be asked is as follows. Let me take the same equation, x square minus 5x plus 1 equals to 0, has roots alpha and beta. Find out the quadratic equation which has roots 1 by alpha and 1 by beta. Now, whenever you get this kind of questions, what you use is something like this. You see what the transformation is. So alpha becomes 1 by alpha, beta becomes 1 by beta. The transformation is an inverse transformation like this. X becomes 1 by x, right? So whatever this transformation is going to become, you take a new variable y and you write y is equals to 1 by x. Okay. And now you only need to convert this equation. So once you take y equals to 1 by x, what you do is this. You find out from here that x is going to be 1 by y. So you simply find out the first you say make the substitution according to the rule, whatever the rule you're seeing from the old roots to the new roots. Then you simply solve for x from that new rule and you put it back in the equation that was given to you. So you get 1 by y whole squared minus 5 by y plus 1 equals to 0. And then you simplify it to make it a quadratic equation. So you basically multiply by y square. So what do you get? Y square minus 5y plus 1 is equals to 0. And this would mean that you have 1 by y square plus minus 5 by y plus 1 equals to 0. And that basically gives you the same answers. So this is how this entire thing works here. You can easily see how these equations are similar, and that was the point of taking this equation of why these equations have the same roots as their reciprocals. And this is true because alpha into beta was 1, if you remember. So alpha is equals to 1 by beta, and beta is equals to 1 by alpha, which is hilarious here. Anyway, so these are the two kinds of topics that you need to study. And for any practice for this related problems, what you're going to do is you're going to download the app, which is in early access right now, and you can simply go and generate tests as much as you want. And once you generate tests, you solve them. If there's an error, let me know. But most importantly, there is a community feature, which is simple. You simply go, put a question, write in LaTeX your question or whatever, and post it, and someone will answer it. Even one of the admins or experts, or maybe other users. That's it. No other features are required, and it's a very simple app, but it's very helpful because of the unlimited AI assistance that you're going to get. So you can click the link in the description first to join the Google group since it is in early access and it's not been fully published yet. It will be on September. So first join the Google group by clicking the link and then join group and then simply download the app from Play Store. Anyway, that should be it. And hopefully you understood most of the lecture here. So I will continue with many other topics very soon. So thank you for watching. If you're new here, do subscribe. Thank you.